Hey, welcome to CPM 3. This is Module 3, Lesson 6. This is going to be another one of those long lessons that we're going to split over 2 different lectures. Hopefully in the first day, whoever's teaching gets to at least example 5, if not starts example 5. And then the next person will start either in the middle of example 5 towards example 6. Just kind of depends how far the first person gets and the second person's going to pick up. But this is going to be split over 2 different lessons, okay? So, this whole module has been over quadratic functions. So we have factored, we've used the quadratic formula, we've solved by factoring. Now we are going to actually start graphing these. And when you have a quadratic function, and again, a quadratic function is anything that has like that squared x, okay? When you have a squared term and that's your highest exponent, you're going to be given these quadratics, and they make the shape of a parabola, okay? Not parabola, okay? It's not a disease, a parabola. So, first thing we're going to do is determine whether that parabola goes up or down, and then going with that, we're going to determine if it has a max or a min. You know that this parabola goes up, and what I mean by up is that it like opens up when a is greater than 0. So in other words, when a is positive. Okay, so then opposite, it's going to go down, and what we mean by down is it opens up down when a is less than 0 or when a is negative. So then once you determine if it goes up or down, then you can say, does it have a max or does it have a min? If it goes down, then you can see exactly how high it goes, but it's going to keep going down forever. So there's no minimal, okay? But it does have a maximum. And then if it opens up, it's going to keep going up in both of these directions forever and ever and ever. But what I can see is that it does have a minimum. Okay, so that's the first thing we're going to do. So we're going to basically just look at A. If A is positive, it opens up. If it's negative, it opens down. So here, example 1, determine whether the graph opens upward or downward. Does this function have a maximum or a minimum? So here, determine what A is. In this problem here, okay, if you don't see anything in front of this x term, then there is a known 1. So my A here is 1. So because A is a positive 1, this is going to open up. So when it opens up like this, make that a little bit better. Okay, we can see down here it has a minimum. Okay, and those two will always go together. If it goes up, it's got a minimum. Here, figure out what your A is. Again, we have nothing there, so that means my A is 1. So that opens up. And because it opens up like so, means I have a vertex down here at the bottom. And so it's got a minimum. And now here, because we've got a negative x squared, now my A is a negative 1. And because it is negative, now it is going to open down. And now when it opens down, my vertex is going to be on the top. So now I have a max. Okay, and just like up and minimum always go together, down and max always go together. Okay, so that's the first thing we got to do is when we look at that, determine if it opens up or down. So Second thing we're going to do is I called these dots right here the vertex. Now we need to be able to identify what that vertex is. Okay, and so if you want an illustration of that, you're either going to have a parabola that goes up with a vertex at its min, or a parabola that goes down with a vertex at its max. But these are the vertex. Okay, and those are probably the most important thing about these parabolas, is you want to see where is it reach the maximum or where does it reach that minimum, and then it changes directions, right? You have that parabola and it's going down, and then you hit that vertex and now it starts going up. This vertex is where it changes directions, right? Or it's going up, now it's going to go down. This vertex is again where it changes directions. So to be able to do that, this is another formula you're going to have memorized. This x equals negative b over 2a. Negative b over 2a, it's got to be memorized. So to find the x coordinate of our vertex, we'll use that formula. And then I know you guys don't really like function notation, but what this essentially means is once you find your x, once you use this formula, you are going to then just plug in x to get your y. Okay, so A, we have y equals x squared plus 4x minus 5. So if I'm using my formula of x equals negative b over 2a, my negative b, well, my b is 4, so my negative b is negative 4, over 2 times my a here is 1. So now just simplify this. We get negative 4 over 2. And negative 4 over 2 is negative 2. Okay, so that's one answer. And I guess I'll circle this because it's not my final answer, but we're going to need that. That's what my x coordinate is. So now to get my y coordinate, right, because these are always in x comma y, now I need to plug in my x. So to get y, we've got y equals x squared. My x is negative 2. And when you put this in, you've got to put in parentheses. Plus 4 times, again, that negative 2 goes there. And then minus 5. Okay, so I'm just taking this equation here, and where I see both of these x's, I am plugging in what I found x to be. So that's just calculator work. Put it in exactly the way it looks, including these parentheses here, right? Because negative 2 squared means negative 2 times negative 2, which is positive 4. If you don't put those parentheses, then this is going to end up being negative 4 here. So you have to put those parentheses in there. Okay, but when you put that in, you're going to get y equals negative 9. So now my vertex is at negative 2, negative 9. So that's going to help us whenever we're graphing these and plotting these points. Okay, let's try 2 more examples of this. So I've got x equals, it's a negative b. So this time, because my b is already negative, right, my b is a negative 4. Now this is going to be positive 4 on the top. Over 2 times a. My a is right here in front, so 1. So I've got 4 over 2, which is going to simplify to 2. So now that I have x is 2, plug in that 2 to both of these x's in your function. Okay, and even though this right here says f of x is just another name for y, so I'm going to say y equals again. So y equals 2 squared minus 4 times 2 plus 4. So again, calculator work. When you put that in your calculator, you're going to get 0. So now my ordered pair is always x, comma y. So my ordered pair is 2, 0. Okay, and one more time. So x equals negative b over 2a. Here, I want you to take a minute to think about what your b is. Notice here and here, your b is whatever is that x term. You have no x term. This would be the same as negative x squared plus 0x minus 4. Your b here is 0. Okay, so I've got negative b. Well, I can't really have a negative 0, so I'm just going to put 0. Over 2 times your a, which is negative 1. Don't really need to simplify because 0 divided by anything is 0, but we technically get 0 over negative 2, so we get 0. So now plug that in. So where I see now on this one just that 1x, we're plugging in 0. So I've got negative on the outside, 0 inside parentheses, squared outside, minus 4. Well, this 0 squared just kind of goes away. And so I am left with that negative 4. So my ordered pair is always x, comma y. So I've got 0, comma, negative 4. Okay, so that's finding the vertex. This vertex formula is super important, so you're going to have to memorize how to get that. You're going to have to memorize this formula, and then once you get the formula, to plug that in. I cannot stress how important it is that you know how to do this, okay? So if you need to pause this video and rewind it, rewatch a problem or two, please do so, because that vertex is very important. All right, turn the page. So we have determined whether the parabola goes up or down by looking at A. When we know if the parabola goes up or down, we know if it has a max or a min. And now we just learned how to find the vertex, the turning point of that parabola. So now we're going to determine the x-intercept or intercepts of a parabola. To do this, it's the same way we did when we graphed linear equations. Given a quadratic equation to find the x-intercept, if there is one, we are going to let y or f of x, because those mean the exact same thing, equal 0, and then we will solve for x. You are going to solve by x by the methods that we have already used up until this point. We have used factoring. So we're going to do one of these examples by factoring. We have used the quadratic formula. Okay, we'll do an example with the quadratic formula. And then we will use one with the square root property as well. So there's 3 different ways to solve these. And so we've got 3 examples. We'll do one of each. Now, if you notice here, it says if there is any, you are not always going to get an x-intercept. You always have a y-intercept, but not always an x. So I'm going to kind of zoom in here. If we look at this chart here, we have examples of when you have two intercepts. So if you can see here, let's go to a better color. Okay, if that max or that minimum is below that x-intercept, it crosses that x-axis in two different points. But if that vertex, if that minimal is above that x-axis and it's going upwards, it never ever touches that line. So you don't have one. Now, same thing happens when it goes upside down. If you have a max and it's below the x-intercept, it never crosses. If you have a max and it goes above, then yes, it crosses at two different points. More times than not, we'll get two x-intercepts, but there's actually something else that can happen where it just grazes the x-intercept and then goes back up. So, for example, it could just, if its vertex is the x-intercept, right? If that vertex is on the x-intercept, pretend like that touched. Okay, it could just kind of touch that x-intercept and then change directions. So not only could you have two intercepts, no intercepts, you can also have one intercept. So I'll maybe put one example right here of your one x-intercept. Okay, so three different things can happen. You can have two, one, or none. So, let's try. We have three different ways to get it, right? We've got factoring, quadratic, and square root property. So, let's just do them in order. We'll find our x-intercepts here by factoring. And so when you factor, you are putting in 0 or your f of x, or your y or f of x equals 0. So I've got 0 equals x squared plus 4x minus 5. So when you factor, first, is it in standard form? Yes, it is, because it equals 0. Do I have a GCF? Nope, there's nothing I can divide out of all three terms, so then we'll go straight into our x. So my a times c is 1 times negative 5, so that's going to give me negative 5. My b term is this 4. So what adds up to b and multiplies to ac, it's going to give me negative 1 and positive 5. Okay, negative 1 times 5 gives me negative 5, but negative 1 plus 5 gives me a positive 4. So now this factors to x equals, 0 equals x minus 1, and then x plus 5. And because I am solving, because we have an equal sign here, you got to take it that one step further and say x minus 1 equals 0 and x plus 5 equals 0. So here you add your 1, and I'm going to get x equals 1. And then here you're going to subtract your 5. So you'll get x equals negative 5. Now I should have read these instructions before we even started, but it says find the x-intercepts if there are any. Write your answers as ordered pairs. So because these are x-intercepts and we have x equals, the first one, when I have x equals 1, means your x coordinate is 1. And what did we put in for zero? I mean for y, we put in 0. Let me scoot this over a little bit. Okay, your second ordered pair is x equals -5, and your y is still 0. See, these are my two ordered pairs. Okay, that's one of either these or these, and it would be more of this, right? And so just to kind of get an idea of what we have actually found, okay, this is going to be something like this right here, where this point is your -5, and this point here is your 1. You have found where that parabola has hit those 2 points. Okay, so that's one option, is to solve by factoring. Good news is factoring is quick if you're good at multiplication. Bad news is not every quadratic is factorable. So we have another option to use the quadratic formula. Okay, so quadratic formula. Your quadratic formula, same thing. We're putting a 0 for that f of x, so I've got 0 equals x squared minus 4x plus 4. So is it in standard form? Yes, it is. So list out your A, B, and C. My A is 1, my B is -4, and my C is +4. So put that into your quadratic formula. Now I'm going to run out of room if I write my formula down here in my space. I'm going to write it up here. Your quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So plug this all into your formula. I've got -b. Well, because my b is already -4 turns to just a +4. Plus or minus the square root of b squared. You have to put that in parentheses, guys. B squared minus 4 times A times C. And this is all over 2A. So when we simplify, we've got 4 plus or minus the square root of something. All over 2 times 1 is 2. So put that in your calculator. In your calculator, you're not putting that square root in, right? Because I got the square root right here. You're doing -4 in parentheses, squared outside, minus 4 times 1 times 4. Okay, weirdly enough, you get 0. The square root of 0 is 0. So I've got 4 plus or minus 0 all over 2. Now, usually when this happens, we split it up. But if you kind of notice here, we're going to get the same answer. 4 plus 0 all over 2. 4 plus 0 is 4. Divide by 2 is 2. When I do 4 minus 0 all over 2, well, 4 minus 0 is 4. 4 divided by 4 is 2. Okay, so yes, usually you split it up, but because this one's 0, you don't really need to. So this one, what this means is I only have one x-intercept. So because I have found that x equals 2, my ordered pair here is 2, 0. Okay, that's my x right there. So this is that one where you have that one x-intercept. Okay, it's going to be something like, well, something like this right here, where it's going to just touch your x-intercept right there at 2, but not go through it. Okay. And then our last one here on C, we're going to solve this one by our third method, which is the square root property. Now, this is the only one I can solve by the square root property because it is missing its b term. So when you have a squared term and a constant, a number, you can use the square root property. That's the only one you can. So still same thing. You want to replace your y or your f of x with 0. So now I have 0 equals negative x squared minus 4. Your square root property said to get your x squared term by itself. I want that x squared term positive, so I'm going to add it over. That cancels. So we've got x squared equals negative 4. Now that I've got that x squared term 1 positive and 2 by itself, opposite of square is the square root. But here, I cannot have a negative under that radical, right? So this means here that this is not a real number. When you get the square root of a negative number, that means we have no x-intercepts. So I'm just going to put none. No x-intercepts. So what that means, I don't really know where this parabola is going, but I know it's upside down. So it's either going to be over here, where it never crosses that x axis, or it'll be over here some way. Okay, or I guess it technically could be like right here, which is actually what we have. So let me just do that. Okay, that parabola never reaches that x-intercept, so we have none. Okay, out of everything you're going to be finding today, this x-intercept one is probably the hardest one. It's not hard to determine whether that parabola goes up or down. Not hard to determine whether it has a max or a min. The vertex has a formula, and it's not a hard one, so that's an easy one too. This one is a little bit challenging. But the last thing we're going to do is determine the y-intercept, and that one's actually really, really easy. So again, just like on linear equations, and opposite of finding the x-intercept that we just did, when you're given a quadratic equation, to find the y-intercept, we are now going to let x equal 0 and solve for y or f of x. You will always have a y-intercept. So, example 4 says to find the y-intercept. Write your answers as an ordered pair. So to find this, all we are doing is plugging in a 0 into both of those x's there. So I've got y equals 0 squared plus 4 times 0 minus 5. 0 squared and 0 times anything are 0, so those go away. And so we are left with just y equals -5. So write that as an ordered pair. Because it is y equals -5, my -5 goes in for my y. And what did we put in for x? We put in 0. Okay, so what we have just found is if this parabola kind of crosses here, I now know that this, I know that this crosses here at -5, right here. And we're finding where it crosses this y-axis. Crosses on this one at -5. So because you have those zeros and it cancels everything out, you'll notice every time we're just going to be left with that constant in the back. So same thing here, y equals 0 squared minus 4 times 0 plus 4. 0 squared 0, and 0 times anything is 0. So we're left with y equals 4. So write that as an ordered pair. My y is 4, so that goes in place of my y coordinate, and 0 for my x. And so what we have found is that parabola crosses, I don't know why that keeps doing that, crosses right here at +4. And then last one here, y equals -0 squared minus 4. Again, 0 squared is 0. And so I'm left with y equals -4. So as an ordered pair, that is going to be 0, -4. You want that y coordinate to be whatever you found y to equal. So what we have found is that y is right here at -4. Okay, so we have found different parts of this parabola. Okay, let's just kind of go back here and review. We've determined whether the parabola goes up or down by looking at A. If it goes up, it's got a min. If it goes down, it's got a max. We have found the vertex. Your vertex formula is that -b over 2a. That gets you your x-coordinate. To get your y, we're just plugging that in. We found the x-intercept. We find the x-intercept by having y or f of x equals 0 and solve for x. We've got 3 different ways to solve for x, either by factoring, quadratic, or square root property. And then we have just determined the y-intercept by plugging in 0 for your x. And if you notice, every single time my y equaled whatever that constant was. Now let's actually get to the graphing portion. So, example 5 says to complete the table with several points, then graph Then graph the parabola by hitting the points from the table and connecting them with a smooth curve. So here are your 4 steps to graphing. First, find the vertex. Second one, that vertex is going to go in the middle box. You're always going to be given 5 boxes, so it will always go in that 3rd box. Okay, so if you even want to say 3rd box, that's fine. Number 3, you're going to go 2 up and 2 down on the x column. Okay, I should probably say column after the x. And then step 4, plug in the x coordinates into the quadratic equation or function to get your y coordinates. This is going to be kind of like finding your vertex on steroids. Okay, so here's what I mean by that. First, we need to find that vertex. Your vertex formula is negative b over 2a. Again, that's got to be memorized. So my negative b is going to be negative 4 over 2 times a. My a is 1. So simplify. We get negative 4 over 2, and that gives me negative 2. So this negative 2 is going to go right here in the middle. Okay, that's step 1. Well, and 2, right? Goes in the middle. So then step 3 says to go 2 up and 2 down on the x. So what I mean by that is 2 up would be negative 1 and 0, and 2 down would be negative 3 and negative 4. Now it doesn't matter if you switch it, right? We could have went negative 4, negative 3, negative 2, negative 1, 0. The order doesn't matter if it's going up or down, but you just need to make sure you go 2 up and 2 down. So then step 4 is all calculator work. Plug in the x coordinates into the equation function, into the quadratic equation or function to get the y coordinates. You are taking these 5 x's and plugging them in to this here to get the y coordinates that go with it. So we are doing 0 squared plus 4 times 0 minus 5. Well, just like before, 0 squared cancels, 0 times anything goes away. And so we are left with negative 5. But you need to do that all the way down the column. When you have negatives, you have to use parentheses. So this one, we're putting in negative 1 into both of these x's. So I get negative 1 squared plus 4 times negative 1 minus 5. This is calculator work. Put that in your calculator with the parentheses, and we will get negative 8. Do the same thing with your negative 2. Negative 2 squared plus 4 times negative 2 minus 5. We're going to get negative 9. Negative 3 squared plus 4 times negative 3 minus 5. We're going to get negative 8. Then our last one, negative 4 squared plus 4 times negative 4 minus 5. And that's going to give me negative 5. Now before we plot these, I want you guys to kind of pay attention to the pattern that has just formed and will always form. This middle one here is my vertex, so it will kind of stand alone. But then directly on top and on bottom of my vertex, I get negative 8 on both of these. And then in 2 up from my vertex and 2 down from my vertex, we get negative 5. That pattern will always be. Okay, so that's a good way to check to make sure is everything correct? You'll have a number here in the middle that doesn't repeat, but then your second and fourth one will repeat, and your first and your last one will repeat. That's how you know you've done this correctly. So let's plot these points. We've got 0, -5, -1, -8, -2, -2, -9. I don't know why that keeps doing that. Oh, this is frustrating. What is going on? Okay, let me try a different method here. We'll just boop, boop, boop. That's a little off. Boop, boop, and boop. Okay. So those are my 5 points. And so it says here, connect them with a smooth curve. So as best as you can. What you don't want is to make this V. Okay, it's not a sharp point. It kind of curves at the end. So as best as you can. Okay, you want that to somewhat curve right there. All right, so if you need to rewatch this example, please do so. We have 2 more like this, and I am going to go a little bit quicker through them. Okay, so if you need something a little bit slower and to get it, a little bit better, rewatch this example because we're going to go through these a little bit quicker. On B, we have x squared minus 4x plus 4. So, first things first, find that vertex. So to do that, we've got x equals -b over 2a. My -b, well, my b is already negative, so -4 is +4. Over 2 times a, my a is 1. So I've got 4 over 2, which is just 2. So this 2 goes in the middle. So now I need to go 2 up and 2 down, and it does not matter the direction we go. So you can either go 3, 4, and then 1, 0, or 1, 0, 3, 4. It does not matter. So now to get these y columns, you need to plug in these for your x. So both of these x's. So what I'm going to do is just put some parentheses here. So you're going to have something squared minus 4 times something plus 4. So what you are doing is you are either putting in, let's say if I'm putting in 0, we got 0 squared minus 4 times 0 plus 4. You're doing 1 squared minus 4 times 1 plus 4. 2 squared minus 4 times 2 plus 4. 3 squared minus 4 times 3 plus 4. And 4 squared minus 4 times 4 plus 4. That's a lot of 4s. Okay, whatever your x is, you are putting them into both of them. So when you do that, for both 0 and 4, because that's the pattern, they need to match, you will get 4. For 1 and 3, you get 1. And for 2, you get 0. So plot those points and connect the dots. So we've got 0, 4, 1, 1, 2, 0, 3, 1, and 4, 4. So make that as smooth and curved as you possibly can. And try to hit all of those dots. And same thing here on B. Or sorry, on C. Find the vertex first. So that's x equals negative b over 2a. This is that one where I have no x, so my b is 0 over 2 times negative 1. It doesn't matter that this is 0 divided by negative 2 because 0 divided by anything is 0. So that goes here in the middle. Now you need to go 2 up and 2 down. So it does not matter if you go negative 1, negative 2, and then 1 and 2. Or if you go 1, 2, negative 1, negative 2. Okay, just go 2 up, 2 down. Because we know that these two are going to match and that these two are going to match. So it doesn't really matter which order you go in. So now with this one, you are putting in these x coordinates into only this one x, and then that will give you your y. Be very careful with this one because of that negative on the outside. The only thing we're putting something in for is that x right there. So that means we have negative on the outside. Let me put this down here. No, it won't. We've got negative on the outside. Then I'm putting in my number here and squaring on the outside, minus 4. So you are putting in these into this one spot here, but when you put this in your calculator, you have to make sure that negative is on the outside. So you've got negative on the outside, 2 in parentheses, squared on the outside, minus 4. Negative on the outside, 1 squared minus 4. Negative on the outside, 0 squared minus 4. Negative on the outside, negative 1 on the inside, squared on the out, minus 4. And negative on the outside, negative 2 on the inside, squared, minus 4. Okay, you're putting all of these into here. When you do that, your 2 and negative 2 will be negative 8. 1 and negative 1 is going to be negative 5. And 0 will be negative 4. So let's plot. And if you can't get these answers, if you can't get your y's, you need to come and see me so that I can help you put this into the calculator. So we've got 2, negative 8, 1, negative 5, 0, negative 4, negative 1, negative 5, and negative 2, negative 8. So now this parabola looks something like that. All right. Last example before we get to the word problems. And now it says we're putting examples 1 through 5 all together here for example 6. So, A, does this graph open up or down, because this A is negative, it's going to open down. A equals -3. So because it is opening down like so, does this function have a max or a min? This has a max. Down and max go together, up and min go together. Okay, and its max is right here on that vertex. Speaking of vertex, C, what is the vertex? So on C, we've got x equals -b over 2a. Let's just go ahead and label these. With my function here, my A is -3, my B is 6, and this time my C is 0. So my -b would be -6 over 2 times my A, which is -3. So we got -6 over -6. So this gives me a +1 for my x. So now plug that in to get your y. So I've got y equals, you're plugging this in to both of these x's. So -3 times 1 squared plus 6 times -1. Okay, that is calculator work. When you put that in your calculator, you will get 3. So what is my vertex? My vertex is x, comma y. So 1, comma 3. D, find any x-intercepts. Okay, I won't lie to you, your x-intercepts are the harder ones. So we can do this by factoring, by quadratic, or by square root property. Well, the square root property actually doesn't apply to this one because we have a b. You can only do square root property when you don't have a b. So we have quadratic formula or factoring. Quadratic formula works with all of them, but I do know we can use this by factoring, so I'm going to factor actually. So when I factor or use quadratic, we're plugging in 0 for our y or f of x. So I've got 0 equals -3x squared plus 6x. Okay, I'm just replacing this with 0. So is it in standard form? Yes, it is. It equals 0. So then, do I have a GCF? Because I have a GCF on this one makes this one the factoring the easiest way. What can I divide out of both of these two terms? Well, 3 and 6 are both divisible by 3. And they both have an x, so I can divide out an x. Now, it really doesn't matter. You'll get the same thing no matter what. But in general, when you are factoring, you want this x squared term to be positive. So I'm going to take out a -3x. So divide everything by -3x, and we're going to be left with an x minus 6. Okay, so what I did there, because my GCF is a -3x, you're dividing both of these terms by -3x. Okay, so I actually made a little bit of a mistake. So I'm glad I did that, because this would be a -2. Okay, and this is really easy to check. Is negative 3x times x negative 3x squared? Yes, it is. Negative 3x times negative 2? Yes, that's a positive 6. So now that I have this factored, set each of these equal to 0. So I've got negative 3x equals 0 and x minus 2 equals 0. So divide here by negative 3, and 0 divided by anything is 0. So this as an ordered pair is 0, 0. And on this one, we're going to add 2. So we'll get x equals 2. Now, it really doesn't say to write as an ordered pair, so you could just say x equals 0 and x equals 2, but if it says an ordered pair, you've got to put 2, 0 as that ordered pair. E, we need to find the y-intercepts. Find y-intercepts, it's the opposite of this right here. I'm putting in a 0 for my x. So I've got y equals, even though this says f of x, I know that's the same as y. Y equals, put in a 0 for both of those right there, for both of those x's. So I've got negative 3 times 0 squared plus 6 times 0. Well, 0 squared is 0, and 0 times anything is 0. So when everything cancels out, this means my y is 0. So again, it doesn't tell me to write this as an ordered pair, so that's acceptable, but an ordered pair would be 0, 0. So when you have something crossing at the origin, that's both your x right here. We have something crossing at the origin, that's both your x-intercept and a y-intercept. F, complete the table. Well, because we found a lot of other stuff, we have quite a bit of this already. So my vertex needs to go in the middle. So we've got 1, 3. I need to go 2 up and 2 down. It doesn't matter which is which, so I can either go 0, negative 1, and then 2, 3. Or we can go 2, 3, 0, negative 1. It doesn't matter. But like I said, some of this we already have. So right here, when x is 2, your y or your f of f is 0. When x is 0, you can either grab it from here or here. Whoops. But that is 0, which should make sense, right? Those are supposed to match each other. So the only thing we're really needing to plug in is that 3 and that negative 1. So, in place of both of these x's, you're plugging in what we say x is. So I've got negative 3 times 3 squared plus 6 times 3. Down here we've got negative 3 times negative 1 squared plus 6 times negative 1. Parentheses are nice and helpful. So with both of those, when we plug that in, we get negative 9. And by the way, if you're just putting this in your calculator and getting the negative 9, you can know that this needs to be negative 9, but it does help if you put this in your calculator. That's a really good way to check and make sure you've done it right. So now G, sketch a graph. So 3 and negative 9, 2, 0, 1, 3, 0, 0 in the origin, and negative 1, negative 9. So here we have a super skinny parabola like so. Okay, so that has a little bit of everything in this that we've done. So this is a really good review of what the first 5 pages were about. Our last 2 pages, and I know we've just gone over an hour. We're going to finish this lesson with word problems. So, this is directly from your My Math Lab homework. Number 18. It says a person standing close to the edge of on the top of a 200-foot building throws a baseball vertically upward. The quadratic function given below models the ball's height above the ground as function t, or s of t, in feet, t seconds after it was thrown. So complete parts A through D. So here's my quadratic function. How many seconds after the ball, how many seconds does the ball reach its maximum height? What is the maximum height? So because it's wanting that maximum height, if you kind of look at this, okay, and I know this is going upside down because my A right here is a negative 16. If it's wanting that maximum height right here, what it is asking for is the vertex. And a lot of these word problems are going to ask basically for the vertex, and you just have to know that in the context of this problem that that's what it's asking for. So down here on A, to find the vertex, that is our formula of negative b over 2a. So my b is 96, so we've got negative 96 over 2 times my a is negative 16. So we've got negative 16 over negative 32, and that's going to reduce to 3. So now to get the y, plug this in. So into this equation here, plug this in to both of our t's. So I've got negative 16 times 3 squared plus 96 times 3 plus 200. I replace this t and this t with what we found. So when you plug all of that in, this is calculator work, you're going to get 344. So that's my vertex. My vertex is 3,344. So when we're talking about this, it wants to know how many seconds does it reach its maximum height and what is that maximum height. Kind of use some common sense here. Does it make sense for us to say that the ball reached a height, here, we'll go here, that the ball reached a height of 3 feet after 344 seconds? That doesn't make a lot of sense if I'm on a 200-foot building, right? So let's switch it. the ball reaches its maximum height of 344 feet, so it already has the units for us, after 3, and again it has the seconds, or units, after 3 seconds. Okay, so that's our part A. Part B, how many seconds does it take for the ball to finally hit the ground? Last lesson, we went over word problems that talked about something hitting the ground. When something is hitting the ground, that means its height is at 0. If it's hitting the ground, it's not above the ground at all. It's hitting it. Okay, height is 0. So I am plugging in a 0 for what this function equals, since that s of t is my height. So I definitely should have left myself some more room here. But we're going to use the quadratic formula. So I'm going to go ahead and put in a 0 in here so I don't have to rewrite that. And we're going to use that quadratic. My quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we've got negative b. My b is 96. So negative 96 plus or minus the square root of b squared, so 96 squared, minus 4 times my a is negative 16, my c is 200, and this is all over 2 times a, so negative 16. Okay, so I've got negative 96 plus or minus the square root of something all over 2 times negative 16 is negative 32. So you're putting in your calculator 96 squared minus 4 times negative 16 times negative 200 in your calculator. Not the square root, just what's under it. When you do that, you're going to get 22,016. Now that's not a perfect square root, so from here, split up into your two answers. So we've got negative 96 plus the square root of 22,016 all over negative 32. When you put that in your calculator, remember to put the top in first, hit enter, and divide by negative 32. We're going to get negative 1.6. Because we're talking about seconds, I can't have negative 1.6 seconds. So we're throwing out that one. So let's try the next one. And I don't know if this is going to mess up with this 7 right here. But now we've got negative 96 minus the same square root all over negative 32. So same thing, put in the top, hit enter, then divide by negative 32, and we get 7.6. So if you need help putting that in your calculator, you got to come see me. I can't do that on this video. So B is 7.6 seconds. So it's going to take 7.6 seconds for that ball to hit the ground. C says find S of 0 and describe what this means. When you have S of anything, that means this is your X, what you're plugging in. So in place of both of these T's, right, usually we see X's. So in place of both of those T's, we're plugging in 0. So we've got negative 16 times 0 squared plus 96 times 0 plus 200. Well, just like before, this is your y-intercept, right? 0 squared is 0. 0 times anything is 0. And so now all I'm left with is this 200. So the value of s of 0 is 200, which is, what does this represent? So we're looking down here now. Does this represent the minimum height of the ball, the height of the building, or the maximum height of the ball? Well, I already know the maximum height is 344. I already know the minimum height of the ball. That's right here at 0. So this represents the height of the building. Which tells me right here, right? On top of a 200-foot building. So then lastly, D, use the results from parts A through C to graph the quadratic function. So, 2 of these we can automatically throw out. I know that my ball reaches a maximum of 344. This one's a maximum of 175. This one's a maximum of 175. So I know it is not B or C because it does not reach that maximum. So now I've got a maximum of 350 and 350. And so that's going to cover that 344. The last thing we know is that it's going to take 7.6 seconds for this ball to hit. Over here, this is a negative 7.6 seconds. So that doesn't work. So that leaves this one here where it is at a positive 6.7. Okay, so that's going to be in my math lab question number 18. All right, you're going to have problems like this on your test and also in my math lab. It says if a ball is projected upward from the ground level with an initial velocity of 192 feet per second, then its height of the function of time is given by this right here. What is the maximum height? So, because that is negative, that means this is going upside down. And it wants to know this maximum height. What is this maximum height? What is its name called? This is the vertex. Okay, a lot of times when they ask for the maximum height, the maximum whatever, they're talking about the vertex. So, find it. X equals negative b over 2a. My negative b is a negative 192 over 2 times a, which is negative 16. So I've got 192 over negative 32. And this is going to equal 6. So what we have just found is the time. We are in seconds here. So in 6 seconds, the ball is going to reach its maximum height. So what is that maximum height? Plug that in to get it. So I've got y equals, you're plugging in your 6 into both of these variables. So negative 16 times 6 squared plus 192 times 6. Calculator work. We're going to get 576. And what unit are we in as far as measurements? We are in feet. Our last example. The number of locations of a certain chain restaurant worldwide can be modeled by the quadratic function or quadratic equation f of x equals negative 77x squared plus 1740x plus 28,493, where f of x is the number of restaurants and x is the number of years after 2000. So, A, will this function have a maximum or a minimum? Well, because my A is a negative 77, that means this is going to go down. And so this top right here is going to be my max. How can you tell? Because A is negative. Okay, A is negative 77. So now B. According to this model, in what year will the number of restaurants be at its maximum or minimum? Again, what are we looking for? We are looking for the vertex. So that is my x equals negative b over 2a. My b is at 1740, so negative 1740, all over 2 times my a is at negative 77, so we get negative 1740 over negative 154, and when you divide, it doesn't come out evenly, but it becomes about 11.3. So it doesn't want to know in how many years, it wants to know in exactly what year. Well, my years are after 2000. So I'm going to say 2000 plus, I'm just going to call that 11. Okay, it's closer to 11 than 12. So this is going to be in about 2011. So then part C wants to know what is that max or min number of restaurants predicted. That's my y of my vertex. So we've got y equals, I'm going to put in this 11.3 into both of these x's here. So we've got negative 77 times 11.3 squared plus 1740 times 11.3 plus 28,439. This is again calculator work. When you put this in your calculator, it's going to give you a decimal again. And because we're talking about restaurants, we need to round to the nearest whole number. So that's going to end up being about 38,269 restaurants. All right, guys, I know this is a long lesson. Okay, and that's why we split it up into 2 separate lessons. So this is going to be split up between 2 lectures. I mean, not lessons, but 2 different lectures. First lecture is going to get somewhere around example 5-ish. They might get a couple done in example 5. They may get none of it done. They may get all of example 5 done. Okay, but then your second lesson is going to pick up somewhere around example 5, example 6, and finish this out. If you have any questions, especially about putting this information in your calculator, please let me know. Okay, I can't show it in this video. So if you're not able to put something in your calculator and get the answer, come and ask me. And as always, rewind this video and pause it as much as you need to. Bye guys, thanks.